Hello Year 11s, our first topic is quadratics and more specifically solving quadratic equations. Now you would have done this last year, so a bit of revision. Now if you say you're looking at that equation there, 6x squared is equal to 7x, and it's asking us to solve it by factorizing and using the null factor law. Now null factor law, if you recall, null, that involves the number 0. So what is a null factor law again? That's the one that says that if you have two numbers or two variables, a times b, and you know that's equal to 0, what is the only way for that to be true? That would only be true, in other words, if and only if, that's a double arrow, either a is equal to 0 or b is equal to 0. That is a null factor law. So let's get on to this. We have 6x squared is equal to 7x. The first thing is to make it equal to 0. Let's do that. We have 6x squared minus 7x is equal to 0. Next step, we need to have something times something. We need to have it in factorized form. And here, it's not in factorized form. There's a minus in between our two terms. So, what is the common factor of these two terms? Well, it is simply just x. So we do x times 6x minus what? Minus 7 equals to 0. And look at that. Now, it's in this form, a times b equal to 0. That means that either x is equal to 0 or 6x minus 7 is equal to 0. In other words, either x is equal to 0 or x is equal to 7 over 6. Now, notice that I have forgotten to write down the therefore symbols at each line. So, that's it. Done. Next one, again, we have another quadratic equation, and it's not equal to 0 yet. Let's make it equal to 0. We have x squared. Now we have plus 2x minus 8 is equal to 0. Now, how do we factorize this? Well, you did this last year over and over again. Reminder, look at that. Quadratic, it's a monic quadratic. The coefficient of x squared is 1. So let's do this. How do we do this again? If you recall, well, the minus 8 is the product, the 2 is the sum. So can you think of two numbers that when you multiply them together, you get negative 8, and when you add them, you get 2? Well, hopefully you would tell me that the numbers are 4 and negative 2. Well, let's use this again. How do we do this again? Well, this becomes x plus 4 times x minus 2 equal to 0. And look at that. Look how good that is. Again, null factor law. Either x plus 4 is equal to 0 or x minus 2 is equal to 0. In other words, x is either equal to I forgot to equal 0 there. So either x is equal to minus 4 or x is equal to 2. Done. Now, perfect squares. Perfect squares. Have a look. A squared plus 2ab plus b squared. Do you remember what that is? What about the one below? A squared minus 2ab plus b squared. Well, hopefully you remember that it's equal to this. A plus b all squared. And the one down the bottom is a minus b all squared. And if you've forgotten that, well, perhaps write it a few times until you remember it, because that's one of those useful rules, useful formulas. It's so good to know. How are we going to use that here? Well, let's have a look at this here. We have this quadratic equation to solve now. Now, the first step is always the same. Make it equal to 0. So let's start with 81x squared. Where am I going to put the 72x? Next to the first term, so that way it's in the middle. So that's equal to 0. Okay, now I was telling you about the perfect squares. Now, when you see the number 81, what squared gives you 81? 9. So what about 81x squared? Well, that would be 9x all squared. Okay, what about the 16? 16? 4 squared. Okay, let's put the 4 squared like that. Now we've got this minus 72x. I'm going to ignore the minus 72x for now. And I'm just going to say, well, first of all, hang on, there's a negative. Or it's looking like that one. So what if I try to write it in this form? What's my A? My A is 9x. What's my B? My B is 4. Okay, let's give this a go then. The minus stays where it is. I'm not going to write 72. There's a 2 there. I'm going to write the 2. 2 times what? 2 times A. That's 9x. 2 times 9x times, what's my B? My B is 4. Okay, let's see. Does this give me negative 72x? 2 times 4 is 8. 8 times 9 is 72. Look at that. Yes, we can write it in that form. Well, this means that we can write it in this form. Let's do it. We have 9x minus 4 all squared equal to 0. And we can solve this straight away now, because if you have something squared is equal to 0, well, that means the inside must be equal to 0. There's no other way around it. That means that 9x is equal to 4, and x is equal to 4 over 9. Again, I've got this habit of always forgetting to write down my therefores at the start of every line. Okay, and we have solved it. Now look at this thing though. Notice that x was 4 over 9, and we only got one answer for x, whereas before we were getting 2 answers for x. And that is okay. Sometimes you'll only get one answer. Okay? Now the next one is the tricky part now. For questions D and E, it's telling us that we could solve it by either using what's called splitting the middle term or by the cross method. Now we're going to practice both here. So first of all, let's practice splitting the middle term. Again, there's no other way but to make everything equal to 0. So we have to bring everything to the left. So when I said everything equal to 0, I meant the equation equal to 0. That is our first step there. Always the same. Now, our quadratic equations, like in the general form, it's ax squared plus bx plus c equal to 0. Now, to split the middle term, we do a times c. In other words, what's a? 6. What's c? Negative 10. What's 6 times negative 10? Negative 60. Okay, that's the first step. Next step, we write down the factors of negative 60. Forget about the negative for now. What times what gives you 60? Well, we just had 6 times 10. Okay, now, where should I put the negative? With a 6 or with a negative 10? Well, I'm looking for two numbers that when I multiply them, yes, I get negative 60, but when I add them, do you remember what we need to get? We need to get negative 11. So if I put the negative 6, the negative there, or the negative there, either one, I'm not going to get negative 11. No good. What else gives you negative 60? What about 2 times 30? Let's put the negative with the 30. No, 2 minus 30 is not negative 11. No good. What about 4 and 15? That gives me 60. So if I put the negative with the with the 15, 4 times negative 15, negative 60. What's 4 minus 15? Negative 11. That's what we need. So these are our numbers, 4 and negative 15. Doesn't matter in what order you put them. It could have been negative 15 and 4. It will still work for our next step. So here we go. After all of this, it is called, let me just change the color here, because it's called splitting the middle term. The middle term is negative 11x. I'm going to write it as 4x minus 15x. That is still equal to negative 11x. That 6x squared stays where it is, and so does everything else. Now, what would we do this again? Well, look at this now. What's the common factor between these two? It's a 2x, and anything else? No, okay, it's 2x. So 2x times 3x gives me 6x squared, and 2x times 2 gives me 4x. Alright, now what do these two have in common as a common factor? Negative 5. Okay, negative 5 times what gives me negative 15x? 3x. And then what? Plus 2. But after all of that, look how good this is. Let me change the color here to make it a little bit easier to see. This is one term. This is my second term. What are the factors of the first term? The factors are 2x and 3x plus 2. What are the factors of the second term? 9 minus 5 and 3x plus 2. What's the common factor there? 3x plus 2 is the common factor. Okay, so my next bracket is going to have to be 2x minus 5. So now, it's our usual stuff. We say therefore either 3x plus 2 is equal to 0 or 2x minus 5 is equal to 0. In other words, either x is equal to negative 2/3 or x is equal to 5 over 2. Okay, so that is what we call splitting the middle term. We could have also done the cross method. Let's do the next question using the cross method. Okay, so when you look at the next equation here, what is the one thing that you don't like? Something looks different here, and it's that x in the denominator. And we get rid of x's in denominators if we can. Now, how do we get rid of that x in the denominator? Well, it goes like this. If I were to ask you, say, 2/3, what would you multiply 2/3 by for that 3 to disappear? What would you multiply it by? By 3. Okay, that would become a 2. Alright, so what if I gave you the fraction, say, 4 sevenths? What would you multiply that by? By 7. Okay, so what about 8 over x? What would you multiply 8 over x by? If you multiply by x, the x's cancel out and you're left with 8. Okay, well let's do it then. Now, please remember, whatever you do to one side of the equal sign, you have to do it to the other side of the equal sign. But you have to do it to everything on the one side. What do I mean by that? Let me rewrite this 3x plus 8 over x. And we're going to multiply the whole thing by x because we would like that x in the denominator to disappear. So I'm going to have to multiply both sides of the equal sign by x. Let's expand the left-hand side. 3x times x is 3x squared. And now we have plus 8 over x times x. We said that is equal to 8. And that gives me negative 14x. Now, as per usual, we make the equation equal to 0. Let's do that. 3x squared plus 14x plus 8 equal to 0. Now, we could do splitting the middle term here, but I would like to remind you how to do do it by the cross method. Now, cross method, it goes like this. A is 3 and our C is 8. Then you write down the factors of 3, which in our case here, we only have 1 and 3 to worry about. And 8, it could be either 1 and 8, or 8 and 1, or 2 and 4. And that's nothing else. So now it's a matter of, if you like, trial and error. 1 and 3, there's no other option there. You use that. Now, the tricky part here is that, yes, I could use 1 and 8, or I can use 8 and 1. I could use 2 and 4, or 4 and 2. But if I use 1, I must use 8. If I use 2, I must use 4. Okay, I can't say and do use 1 and 4. It doesn't work like that. Let me go and put a 1 and an 8 here. Cross method. Cross like this. And you multiply across. 3 times 1 is 3. 1 times 8 is 8. To add these, 8 plus 3 is 11. Now, I need to get 14. Okay, this combination, no good. Let me just try and put 8 on top here and the 1 down the bottom. What would we get? 3 times 8, 24. 1 times 1, 1. 25, no good. Okay, time to move on now. 8 and 1 was no use. Let's try 2 and 4. Let me put a 2 and the 4 there. See how we go with this. 1 times 4 is 4. 3 times 2 is 6. 6 plus 4 is 10, not 14. Let's try something else. Let's put the 4 up here instead, and the 2 down there. 3 times 4 is 12. 1 times 2 is 2. Okay, 14. Lovely. That's exactly what I need. But how is this useful? Let me just change the color here for it to become obvious. We have to go across like this. So I can factorize this as we have 1x plus 4. Let me write it down, x plus 4. Our next factor is going to be, have a guess, 3x plus 2. And now we solve it as we always do. Look, all of these therefore shouldn't be in there, okay? They should have been in every single line. So we have either x plus 4 is equal to 0 or 3x plus 2 equal to 0. Okay, so therefore either x is equal to negative 4 or x is equal to negative 2 thirds. Right, let me just select this so we can answer the next one. Now before we even answer the next one, if I were to tell you, can you think of any number at all? You know what? Let's call it I don't know, z. If I have z squared is equal to 100. If I were to ask you, can you think of any number such that when you square it, you get 100? But now what if I told you, can you tell me all of the numbers that when you square them, you get 100? Yes, you would have told me at 10, but can you think of any other number that when you square it, you also get 100? What about negative 10? Negative 10 times negative 10. Does that also give us 100? Yes, it does give us 100. So that means that this equation here has two possible solutions. They are positive 10 and they are negative 10. Now, be careful. Whenever you, the opposite of squaring something is, plus or minus the square root. Okay? Don't forget that. That is something that students always forget over and over again. But with lots of practice, you won't forget. So look at this one now. X squared is equal to 9. What's the opposite of squaring something? Well, we just said plus or minus the square root. What's the square root of 9? What squared gives you 9? 3. Okay. X is equal to plus or minus 3. Okay, done. Next equation. Look at that. We have x plus 1 all squared equal to 81. I don't want you to expand this. Please do not expand the left-hand side. We can solve this in a simpler way. Now, look at this. What is the opposite of squaring? Plus or minus square root. Let's do it then. X plus 1 is equal to plus or minus square root of 81. In other words, x plus 1 is equal to plus or minus what? Plus or minus 9. Okay, let's keep going. How does plus 1 go to the right-hand side? As negative 1. Okay, so negative 1 plus or minus 9. And we're almost there. What's negative 1 plus 9? 8. What's negative 1 minus 9? Negative 10. Okay, let's go and check. If x is 8, 8 plus 1 is 9, 9 squared is 81, perfect. What about negative 10? What's negative 10 plus 1? Negative 9. Negative 9 squared, 81. Excellent, it works. Last one. X plus 7 all squared is equal to negative 2. Alright, let's give this a go. Look at this now. X plus 7 is equal to, how do I move that square again? Plus or minus square root of negative 2. And now we have a problem. Now, before we continue, if I were to ask you, what is the square root of negative 100? Can you give me an answer? I bet if you go quickly, you might tell me, hey, the square root of negative 100 is, you might tell me it's negative 10. But careful, does negative 10 times negative 10 give you negative 100? No, it doesn't. So, is it possible for us to get a value here? The square root of negative 100. Well, there is a value, but it's imaginary value, and we are not going to learn about imaginary numbers just yet. So look, if you ever have a case of square root of a negative number, we say that it is not a real answer. There's not a real number. So in this case, you would say, therefore, no real solutions exist. So whenever you have, say, I don't know, square root of -5, you say, hey, that's not a real number. You know, with the knowledge that we have so far, we can't do it. And we say that no real solutions exist. Now, last one. This one here is not in the booklet. If you like to copy it down in your booklet, you'll see at the end of the booklet there are some extra pages there. Go for it. You can write it. Now, again, notice that x is in the denominator, but in this case, it's on both sides. This equation is not as bad as it looks, because we do what's called cross multiplication. Okay? So what is cross multiplication about? Well, it goes like this. The denominators, we move them to the other side, multiplying. That goes up there, that goes up there. So let's give it a go. So this x stays where it is, but the x plus 8 goes multiplying. Equal sign, the 5 stays where it is, the x plus 2 goes multiplying. Because it was dividing before, goes to the other side, multiplying. Well, let's do this then. Let's expand. We have x squared plus 8x equal to 5x plus 10. And as per usual, move everything to the left-hand side. We have x squared plus 8x minus 5x minus 10 equal to 0. Look, I'm not going to continue any further. I'll let you finish this, because now you should have the skills to be able to do this. Now, I would like you to please do 2A.1, the questions that are there on the bottom of the screen. Also, they appear in the booklet, and once you finish those questions, please come and watch the next video, which is for 2A.2.